Okay, let's continue. Right, calculus. Let's open two files. Looks like this is where we were at 26 and 27. Okay. And then let's open up the solutions. Okay. All right. Well, it's actually too bad the graph. If you were to graph that, that's x, that's y. So x equals y power 4 would be this graph. And then this one here, oh, well, kind of cubic shape. It's a bit hard for me to draw. I think it would look like that. So we're looking at this region here, this being the 0.11. So it'd be, the area would be y power 5 minus y power 4 dy 0 to 1, I think. So that'd be y power 6 over 6 minus y power 5 over 5, 0 to 1. So that, let me put my light on. 1/6 minus 1/5 is, oh, and it's a negative, so that means I actually had it backwards. 30th. So I better graph it now, since I might have had the wrong picture in my mind. X equals y power 5, and then x equals y power 4. Okay, it's flatter than what I thought. Well, that does look like 1, but oh, because it's 0 to 1, the y5 collapses faster than the y4. Yeah, so I do have it the wrong way around, so I can correct that by just putting the minus in the front. Yeah, so that's not quite it. It's quite an extreme shape. Very small area, as you can see. Now let's graph this one, xex and ex. Oh, but just regular y. Okay. Y equals e power x. And then y equals x e. Okay. Okay. Well, that's a clear cut. And are we told to go from 0? Because that would probably be needed. 0 and 1. Yeah. Okay. So from 0 to 1. So if I just put in x equals 1, we can more clearly see the area we're talking about here. It's this area here. So it's the, yeah, okay, so it's the exponential minus xe exponential dx 0 to 1. In fact, that kind of looks, if it wasn't for the minus, it would look like the derivative of xex, because the derivative of xex would be ex plus xex. that's quite close. It's unfortunate about the minus though. Pity. Pity, pity, pity. So I'll have to use a substitution, but let's just split it into two because the EX, that's A-okay. It's really the problem with the XEX. And that's going to require a substitution. The substitution would be let U equal XCX, I think, actually, because then du dx would equal EX plus XEX. So then that means U with the limits would equal EX integrated with the limits plus XEX integrated with the limits. So this I can change into 0, 1 EX dx minus, and if I just take this over to the other side, the U, which is XEX 0, 1 minus the integration of EX 0, 1 dx. Yeah, that's it, just those two, because I've replaced this with this minus this. Okay, so in fact, you can see that I wonder if I've made a mistake here. Wasn't expecting those to cancel. I guess I did separate it out. Oh, I have to be careful now because there's a minus on the front here. So it will be minus this. That's better. So that means these two add together to make two of them. 2EX 0, 1 minus XEX 0, 1. So if I put in 1, I get 2E, and 0 minus 2E 0 minus 1E 1 plus 0E 0. So that's gone. That's 2E minus 1E is E minus 2. So roughly 0.718. Let us see. What number is that? 27. E minus 2. Yeah. E minus 2 is correct then for this.